Hello everyone, these are the notes for Unit 4, Lesson 1, Noble Gas Envy. For the guiding question, by the end of this you should be able to answer, how can you determine an ion's charge based on the atom's placement in the periodic table? The do now is located here, yada yada yada. And the lesson directions are here. In case you were absent, make sure you are reading number 3 for this. And the answer key for this activity is also posted for you guys, so you can reference it and answer the questions for this on pages 3 and 4. So now we're going to get to notes. The charges on ions are quite predictable. You should have seen this in the activity. When electrons are removed from or added to an element, the rest of the atom stays the same. There is no change in the number of protons. There are no changes in the number of neutrons. The identity or DNA of that element is unchanged. So you still use its elemental symbol. We don't use the noble gas symbol to represent an ion. We use the element we're talking about symbol. The only way we say, hey, its electrons look like that noble gas is by writing the charge based on whether it lost or gained electrons. Okay? So since nothing happened to the protons, the atom is still the same element. The charge in an ion is noted with a superscript, or I hear a lot of the times exponent. Maybe I can spell, who knows. So for oxygen, the -2 charge indicates what? That it gained 2 electrons, right? So a gain of 2 electrons. If we have a +3, if we have a +3 charge, the positive tells us it's a loss of, and then the magnitude is 3 electrons, right? So it works out with the math that the charge should represent that you're losing negative charges. So negative times a negative is a positive, or you're gaining negative charges. So you're adding negative. So positive times a negative is a negative. And then you just have to indicate how many in the charge. Okay. So on the periodic table, we are now going to label each of the group's charges, because you should have noticed that it is very predictable. Because they all have the same number of valence electrons, they will all form the same type of ion. So group 1A forms the 1+ ion. Group 2A we saw forms the 2+. So on the top of your periodic table, label these. 3A forms 3+. 4A was super special and probably irritating. Plus or minus. Turns out they don't do a lot of ions, especially silicon and carbon, but we'll come back to that later. Nitrogen, because it's going to lose electrons, or not lose, gain electrons. Wow. Gain 3 electrons is a -3. Oxygen's group's -2. Fluorine's group, not an F. Wow, fail Miss Bert. 1-. And then the noble gases, because they already have a full valence shell, have no change. That is why they are unreactive. So make sure you put these on there as a point of clarification for our class. It doesn't matter if you write it 1+ or +1. They're both acceptable. There is a difference between the two, but it is not covered in this class. Okay? Also, if the order of magnitude is 1, because chemists are lazy, we don't always write it. So if you just see a positive, like on page 3 in the lesson, you saw a positive for sodium and a negative for fluorine, but no number, it's because chemists are lazy and we don't write it if it's 1. You will not be taken off points if you do write it, and I write it most of the time because it's very clarifying, like it's very clear what that charge is. But that is something that you might see pop up. Cool beans? Okay, there are 2 types of ions. First is the cation with a net positive charge. And remembering that cats are positive, right? Cation. Positive. So cat, positive ion, T, plus sign. Cool. So the cat ion, and then we have, ready? Oops. The anion, which is a negative ion, or another way I remembered it was onion or anion. They smell bad and they make you cry. Negative, right? Haha, funny. The charges on transition metals are not predictable, so we aren't going to cover those yet. We'll come to them in the second half of the Thursday, Friday block. And in case anybody missed it, period 4 is live. Okay, continuing. After an electron transfer occurs, the electron arrangement of the resulting ions looks surprisingly like the electron arrangement of noble gases. Atoms tend to lose or gain electrons to attain the electron arrangement of the nearest noble gas. This is tied into what is called the octet rule. Octet meaning that prefix means 8, the magic number 8. The only exception is helium, but that's because our 1s orbital, or the first ring, first energy level, only holds 2 electrons, so we say it does a duet, because it's 2. Okay, and so that magic number 8 that we're always going to keep trying to combine in ratios that lead us to that stable number. Okay, so checking in. Please pause the video and complete the check-in for these questions, and then resume the video once you have completed that. Okay, so checking your work. You probably drew out the whole Bohr model. You are cute. First ring should have had 2 electrons. Miss Bert's lazy. Second ring should have had 8. Third ring, 8. Second ring, 2. I hate doing Bohr models. Sure. We will also talk about Lewis dot diagrams. How many valence electrons does calcium have? 2. So we can use its element symbol to represent the atom, and then just draw 2 electrons to show the electrons that actually participate in any chemical reaction. So if we're like modeling the ionic bonding, we could say, hey, it's going to give up 2 electrons. And that is sufficient, because does it do anything with its core electrons? No. So drawing the extras is a waste of time. Okay? Explaining what happens to those, like it's going to lose 2 electrons, right? To have electron, like its electrons look like argon. Okay? This requires fewer electrons to move, right? It could lose 2 or gain 6. Like it has to get to a noble gas, because that's what's considered stable and happy and full. And it's like the perfect life, because they're like nobility. Ew, but hey, if the analogy works, kind of. So losing 2 or gaining 6, it's going to pick the one that requires the fewest steps, right? Because each step requires energy. So losing 2 electrons requires less energy than gaining 6. So fewer electrons to change to get the electrons like the noble gases. Make sense? Hopefully. Then not, yeah, it is page 2. Answer the guiding question at the bottom of page 2. Make sure you're using 2 to 3 complete sentences. Some of you are pretending to be illiterate, and it's not okay. And then when you are finished, make sure exit ticket number 9 has made it into the tray. If you are absent, you are excused.